Over 70 million tons of aluminum are produced annually to manufacture everything in the modern world, from giant intercontinental aircraft and advanced electric cars to billions of cans of soft drinks consumed globally. But few know that the journey to unlocking this gleaming silver metal begins in massive reddish-brown ore deposits, where hundreds of millions of tons of bauxite are dug from the earth and fed into the planet's most energy-intensive refining process.
So how do those ordinary layers of red earth transform into pure, refined aluminum? Join me inside these colossal aluminum production complexes to discover the entire journey.
The process of producing aluminum begins in massive open-pit bauxite mines. In fact, aluminum hardly exists in its free metal form in nature,
but is primarily found in bauxite ore. This ore is usually distributed quite close to the surface,
typically at a depth of only about 1 to 10 meters below the topsoil and vegetation. Before mining, bulldozers and excavators remove this topsoil
to expose the characteristic reddish-brown ore layers beneath. This red color mainly comes from iron oxide,
one of the naturally occurring components of bauxite. In reality, bauxite is not pure aluminum but a mixture of various minerals. Aluminum-containing compounds typically account for about 60% by weight,
with the remainder being iron oxide, silica, titanium, and various other natural impurities.
Once the ore body is exposed, large hydraulic excavators begin digging and loading the ore onto giant mining trucks.
Interestingly, unlike many other hard metal ores, bauxite is relatively soft. So many mines don't even need explosives to break up the rock.
This allows for faster and more continuous mining. At a large-scale bauxite mine, production can reach tens of thousands of tons of ore per day.
Countries like Australia, Guinea, and China are currently leading in production. After being brought up from underground, the ore is transported by truck to preliminary crushing plants. In mines located near processing plants, the ore is often transported via conveyor belts, several kilometers long.
The train, loaded with full ore, quickly moves to the receiving area, where the entire unloading process is carried out. At this facility alone, the railway network serving the transportation of ore has a total length of up to 6.5 kilometers. In some countries lacking aluminum refining technology, such as Guinea, they typically export bauxite directly, loading it straight into massive containers waiting at the docks, where huge conveyor systems continuously unload streams of reddish-brown ore onto massive cargo ships. From there, the bauxite continues its journey to factories in countries like China. Technically, when traveling to the refinery, bauxite ore is dumped onto a central conveyor system. Here, giant machines,
running on rails, receive the material and distribute it throughout the entire storage area.
When the plant needs to be resupplied, the recovery head of the machine slowly scrapes layers of ore from the storage pile onto the cylinders to move along a series of conveyor belts stretching for kilometers before entering the refining area. However, despite before aluminum can be produced, the aluminum within the ore must be separated from a host of other natural minerals and impurities.
And that's the job of a refinery. Upon arriving at the refinery, bauxite ore cannot be transformed into aluminum immediately. First, it must be refined into alumina, a pure white powder that serves as a crucial intermediate raw material. Only then does the alumina undergo a highly energy-intensive electrolysis process to produce the metallic aluminum we use daily. Normally, 4 tons of bauxite are refined into 2 tons of alumina, and then smelted into 1 ton of aluminium. Upon arrival at the plant, bauxite ore is first passed through vibrating screens to remove unwanted impurities. Next, the ore is sprayed with water and pre-washed to remove dust and clay adhering to the surface. After being cleaned, the ore continues to move on conveyor belts to giant crushing tanks filled with steel balls. As the drums rotate continuously, thousands of balls collide, grinding the ore into a fine powder. This powder is then fed into the Bayer process,
a refining technology that has been used in the aluminum industry for over a century. Here, the ore powder is mixed with a highly alkaline caustic soda solution and heated to high temperatures. Under these conditions, the valuable aluminum within the ore dissolves into the solution, while impurities such as iron oxide,
Clay and silica are separated out as red mud. The aluminum-rich solution is then filtered and cooled to form white aluminum hydroxide crystals.
These crystals are then heated to high temperatures to remove the remaining water, producing alumina.
A pure white powder that will become the raw material for the next stage of aluminum production. From the calcination area, alumina is transported along conveyor systems, stretching hundreds of meters to storage. During this process, a continuous flow of hot air helps remove any remaining moisture, ensuring the alumina powder is dry and stable before use. At the end of the journey, this pure white powder is collected in giant silos and warehouses,
awaiting transfer to the electrolysis plant. The red mud discharged after this Bayer process.
This contains very high levels of iron oxide and can only be discharged into huge open-air reservoirs. To produce 1 ton of aluminum, factories typically generate about 1.5 tons of red mud, causing environmental pollution.
After being transported to the aluminum smelter, alumina is fed into giant electrolytic tanks containing molten cryolite.
Technically, this substance helps lower the processing temperature from over 2,000 degrees Celsius to around 950 degrees Celsius, allowing for more efficient aluminum production. However, to produce metallic aluminum, oxygen atoms must still be separated from aluminum oxide, using extremely high electric currents. This is one of the most energy-intensive stages in the entire metallurgical industry. On average, to produce 1 ton of aluminum, factories consume approximately 13,000 to 15,000 kilowatts of electricity.
Inside the electrolytic tanks, alumina essentially exists as aluminum oxide, where aluminum atoms are tightly bonded to oxygen. Extremely high-intensity currents flow through carbon electrodes and begin to break these bonds, separating the aluminum from the oxygen.
The oxygen atoms move upwards and react with the carbon electrodes, forming carbon dioxide gas, which escapes.
This also means that the carbon electrodes are constantly being consumed and must be replaced periodically throughout the operation.
On average, to produce 1 ton of aluminum, factories can emit about 2 tons of carbon dioxide.
Meanwhile, the heavier molten aluminum gradually settles to the bottom of the tank. At a temperature of approximately 950 degrees Celsius, this layer of liquid metal is sucked out using a specialized vacuum system and transferred to the finished product casting area.
Molten aluminum is stored in giant vats and transported to the foundry.
Here, engineers typically use specialized tools to skim off the slag and impurities floating on the surface of the molten metal.
These materials may include aluminum oxide residue and other impurities generated during the electrolysis process. This is the first time in the entire process that the bright, silvery metal we are familiar with is actually created.
Next, the molten aluminum is fed into giant mixing furnaces, where engineers can precisely adjust the metal's chemical composition. Depending on the intended use, elements such as silicon, magnesium, or manganese are added to create aluminum alloys with different properties.
During this process, the molten metal is further processed to remove any remaining impurities.
Inside the mixing furnace, fluxes are added to collect impurities that float to the surface in the form of slag. This slag is then removed, ensuring the aluminum achieves the necessary purity and quality before entering the casting stage. In another area of the plant, the casting system has been heated and prepared.
Molten aluminum is fed from the mixing furnace to the casting machine via specialized distribution chutes.
Here, a stream of red-hot metal is continuously poured into casting molds, or a semi-continuous casting system that operates without interruption.
When exposed to the cooling system, the aluminum begins to solidify and gradually forms standard-shaped blocks of metal.
Depending on the intended use, these can be cast into large aluminum ingots, round billets, or massive sheet metal ingots.
The aluminum ingots continue to move along an automated conveyor system, where industrial robotic arms
continuously pick up, stack, and arrange the ingots according to a predetermined configuration.
Once complete, aluminum bundles are secured and prepared for shipment to manufacturing plants around the world.
Besides small aluminum ingots, some factories shape molten aluminum into massive blocks weighing tons, which are then transformed into giant.
Here, the aluminum ingots are first heated in large furnaces to soften the metal. Once they reach the appropriate temperature, they are passed through a series of giant steel rollers operating under extremely high pressure.
With each pass, the aluminum is gradually compressed and stretched, while its thickness continuously decreases. Between these stages, the metal surface is cleaned with a high-pressure water jet system to remove oxides and impurities generated during processing. After many consecutive rolling passes, the aluminum blocks, tens of centimeters thick, are finally transformed into metal strips kilometers long. In the final stage, the aluminum strips are fed through an automated winding system. Layers of metal are continuously wound tightly around a steel core at high speed, creating giant aluminum coils that can weigh up to tens of tons. These aluminum coils are stored and prepared for distribution to the global aluminum industry. So you've learned the whole process, from the layers of red bauxite lying silently beneath the Earth's surface to the gleaming silver aluminum ingots and giant metal coils. The journey of aluminum production is one of the most impressive industrial processes ever created by humankind.
Aluminum is a lightweight yet durable material present in almost every aspect of modern life.
But its dark side has created pollution from red mud waste that humans cannot handle. Thank you for following the entire journey. I compiled the information from many sources. If you have any questions, please feel free to comment below. Now goodbye, and see you again.